Hello, this video is for learning target 223, which is to perform operations with complex numbers. So we know that we are unable to take the square root of a negative number. So when we're doing our quadratic formula, if we're taking the square root of a negative, it ends up giving us an error in the calculator. Well, to fix that, we have imaginary numbers, and this is the definition of an imaginary number, which is represented by this letter I. So this is an imaginary number. And so today we're going to talk about how to use imaginary numbers in our math. And the first thing we're going to talk about is when we have the square root of a negative. And previously we've just been saying that there's no real solutions, which is true, but those solutions are imaginary and we can actually find them. We find them the same way that we would normally, but we have to pull out an I as well. Let's look at what that looks like. So this first example, I have the square root of negative 64. And remember that I can break down the square root to any number multiplied by any number. So this is the same thing as the square root of negative 1 times the square root of positive 64. And so the square root of negative 1, as we see up here, is just I. So I'm going to convert this to just I. And then the square root of 64, if it's a perfect square, we can find that number. And if it's not a perfect square, we can simplify. The square root of 64 happens to be 8. And so I have I and I have 8, and I just need to put them together. Just like if this were an x, we want the number to come first, so we have our answer, which is 8i. So all you really have to do with negative numbers is you have to pull out the negative and then simplify the positive the same way. So let's do another one. We're going to have to simplify instead of having a perfect square. So this one, we're going to simplify to the square root of negative 1 times the square root of positive 125. Negative 1 is just I. And then the square root of 125 is not perfect. I'll grab my calculator. We get a decimal. So I'm going to want to simplify 125. So I notice that I can divide this by 5 to get 25. And I can divide 25 to get 5 and 5. So now I've broken that down. And then the same way that we've been doing, we want to circle our pairs, pull that out front, and then whatever's left goes inside. So 5 square roots of 5. Now again, I want to write it like this, where the number comes first and then the I last. So my answer is 5 square root of 5i. And last one I want to show you is just if there's a number out front, you just have to be conscious of whatever you're pulling out, you need to multiply by that number. So for example, if there was a 2 in front of this one, I would have to multiply this 5 by that 2 before I found my actual answer. So you can pause this and try these ones. I'm going to fill out the answers for all of these so you can see them, and then push play when you're ready. All right, and here are the answers. So for this first one, I simplify my square root of 90 to get 3 square roots of 10. And then since there was already a 3 out there, I had to multiply those two numbers to get 9 square roots of 10, and then my I. Over here, 47 cannot be broken down, so I have 2 square roots of 47i. And then here are my answers for the rest of these. Note that this one is negative out in front only because that 2 is negative. So this is how you take the square roots of negative numbers. You turn them into imaginary. Now, adding and subtracting complex numbers. This is a complex number. So if you're asked what a complex number is, it is this combination. A is the real part, so that is a real number. And then you're adding onto it an imaginary portion. And it has to go in this order: real first, imaginary second. So to add and subtract complex numbers, all you need to do is add or subtract like terms. So you're basically treating I like its own variable, just like if it were an x. You're only going to add or subtract like terms. So looking at an example, this first one is a subtraction problem. Now, we often make mistakes with subtraction, so I highly recommend changing any subtraction problems to addition problems by adding a line and then changing the sign and everything that comes after. Because remember that 2 minus 1 is the same thing as 2 plus a negative 1. That's basically the work that we're doing to change this. And then I'm just going to combine my like terms. I'm going to do my real portions first. So negative 3 and negative 12 are like terms. And then my i's are like terms. Negative 3 plus negative 12 gives me negative 15. And 14i plus negative I gives me 13i. And that's it. So just combine your real portions, combine your imaginaries, and you are good. Next one, if it's just addition, you don't have to do anything first. Just find your real terms, add them together. 9 plus negative 21 gives me negative 12. And 8 plus negative 9 gives me negative 1i. Now go ahead and pause and do the 2 you tries, and then push play when you're ready to see the answers. And there we go. We have our answers for each. Notice in the subtraction one, I changed it to addition and then changed the sign of both things that came after. Now we got one last thing to look at on the back, which is multiplying our imaginary numbers. And when we multiply, you just have to know that I squared is equal to negative 1. Remember that I, by definition, is the square root of negative 1. This is I. And if we multiply I by I, we're multiplying the square root of negative 1 times the square root of negative 1, which gives us just negative 1. So that's kind of the definition. This is where it comes from. So if you have two i's that you're multiplying together, you want to change that to a negative 1. So whenever we multiply I by itself, change to a negative 1. And put it inside parentheses so that it makes sense with the problem. Now let's look at a couple examples. This first one, we are going to distribute. So we have our 2i, and I'm going to distribute here. 2 times 3 gives me 6. And I don't have two i's, I just have one, so I'm bringing the I with me. Over here, 2 times negative 5 gives me negative 10. And then I times I is negative 1. So now whenever you change something to negative 1, you're going to have an additional step. So I'm going to have to distribute again. And then hopefully you notice this is not the order we want. When we have complex numbers, we have to have the real part first. So I'm just going to switch this to 10 plus 6i for my answer. Similar thing over here, but when you have multiple parts, you can either do the distributive method like I did here. You just have to make sure you distribute the 5 to both and the minus 2i to both. Or you can use the box method. So remember with the box method, we draw our box, we line up our terms, and then we multiply in. So here I get 15, here I get minus 6i, here I get 40i, and then down here I get negative 2 times 8 is negative 16, and I times I is negative 1. So then I can just pull all these out of the box. I'm going to combine my real numbers first. So negative 16 times negative 1 is a positive 16, plus a positive 15 is 31. And then 40 minus 6i is 34i. And so I prefer the box method for most that have more than two pieces. So I just wanted to show you both methods, but you're welcome to do the distribution if you want. So now go ahead and pause and complete those two problems, and then unpause when you're ready to see the answers. And there we go. So in our first one, Notice that the I went away because I had to change this I times I to a -1. And then over here, I should get -42 plus 19i. Thanks, everyone.